Okay, so the next bit is quadratic equations. So just a reminder, what's a quadratic equation? Well, that's an equation in some variable x, in which the variable x squared is basically the highest order term. So a typical form will be a times x squared plus b times x plus c. And the equation would say this equals 0. So this is again something that you recognize. So a should not be 0, because if a is 0, then actually it's not quadratic but just linear. Then we won't have the quadratic term. So the question is, how can you solve such a quadratic equation, ax squared plus bx plus c equals 0? And actually the answer to that question you might recall from high school, or otherwise you have to sort of remind yourself of that. It's called the ABC formula, or the quadratic formula. So how does that work again? Well, what you want to do is compute first the so-called discriminant. And discriminant is a combination of the parameters, the a, b, and c parameters, in particular d equals b squared, the coefficient b, coefficient in front of the linear term x, squared, minus 4 times the a, the coefficient in front of the quadratic term, times c, which is the coefficient in front of the no x, basically. And so once you have computed this discriminant, b squared minus 4ac, then you might want to sort of distinguish 3 different kinds of problems. One is in which d is bigger than 0. Well, if d, this discriminant, this expression here, turns out to be bigger than 0 for your problem, then this equation will have 2 solutions. There will be an x1 and an x2, and one is given by minus b plus the square root of your d divided by 2a, and the other one will be almost the same, minus b minus the square root of d divided by 2a. On the other hand, if this d is b squared minus 4ac, this discriminant expression over here, turns out to be 0 for your particular problem, then there's just going to be one solution. So you might say x1 and x2 are the same actually. Or is its solution going to be, what's going to be minus b divided by 2a. And the final alternative is that if d is smaller than 0, so this discriminant is a negative number, then there's no solution. So then indeed, if you look at the square root of d, well, we cannot define that basically. So there is no x that satisfies that equation. So just to remind you what's the intuition for that. So the intuition is that, you know, these quadratic forms here, they actually are a symbolic version of parabolas. So a parabola has something of this form, and if you look at a parabola and you ask, you know, for what x is this parabola, is this equation going to be 0? Well, it's the same question as asking, so where does, at what values of x does this particular parabola, this quadratic equation, cross the x-axis? So you can see actually 3 different cases. So look at the first case, you know, if for some particular example your a equals 1, your coefficient b equals 1, and c is minus 6. If you then compute this discriminant, you'll find, oh, that happens to be d equals 25. It's a positive number, so there will be 2 solutions. Do we see that? Yes, this red line, which relates to that particular combination of parameters, indeed crosses the x-axis in 2 different points, and those are those 2 solutions to this quadratic equation. The second example is the blue parabola, so in this case a equals 1, b equals minus a, and c equals 16. Well, if you then compute this discriminant, you'll find that d is going to be equal to 0. And indeed, what you see, well, there should be just one solution in that case. And that's true because, you know, there's just one point, particular point in which this parabola is touching this x-axis that actually corresponds to that solution. And the final possibility is that indeed the discriminant is negative. So apparently for these parameter values of a, b, and c, the discriminant turns out to be negative 7. Then there is no solution that corresponds to a parabola that actually never crosses this x-axis, the purple one over here. So that's quadratic equations. So let's have a look at some example. The example is 2p squared minus 6p equals minus 3. Let's just look at this on the slide. So solve 2p squared minus 6p equals minus 3. How do we do that? Well, let's bring this in the general form and basically bring the minus 3 to the left hand side. 2p squared minus 6p plus 3 equals 0. So now we are in this particular form that we need for this quadratic equation. So what are the parameter values for this particular equation in p? Well, the parameter that multiplies this square term, the a parameter, is 2 in this case, a equals 2. The parameter that multiplies the linear term, the p term, minus 6, and b is minus 6, and the constant term here is the 3, c equals 3. So what do we need to do? Well, we need to calculate the discriminant for these particular parameter values. So the discriminant is here, b squared minus 4ac. That was the expression in terms of these parameters for the discriminant. So let's plug in those numbers. B squared, so what's b? B equals minus 6. Minus 6 squared, that's 36. Minus 4 times a times c, so a is 2, c equals 3. So this is minus 4 times 2 times 3, or in other words, minus 24. That gives us a total 36 minus 24 equals 12. So obviously that's a positive number. 12 is a positive number. So in this case, the discriminant d is a positive number. And remember, that means there will be two solutions. So what are those two solutions? What do we need to do? We need to take the square root of that discriminant. So the square root of 12, in this case, the discriminant d is 12. Square root of 12. Well, actually, you can rewrite the square root of 12 a little bit and saying, oh, that's actually the square root of 4 times 3. Or in other words, the square root of 4 times the square root of 3. And the square root of 4, well, we recognize that hopefully will be 2. It's 2 times the square root of 3. So the square root of the discriminant in our case is 2 times square root of 3. So now let's plug that in this particular expression from the ABC formula. What are the final answers here for this equation? Compute those by looking at minus b. So again, it was b. B itself was minus 6, so minus b is going to be 6. That's what we see here. Plus or minus the square root of this discriminant, and the square root of this discriminant was 2 times square root of 3. So plus or minus 2 times square root of 3. And then last thing, we have to divide this by 2 times this parameter a. 2 times a equals 2, so 2 times 2 equals 4. And there we are, 6 plus or minus 2 square root of 3 divided by 4. If you look at this, you can actually simplify this a bit. I say, well, 6 divided by 4, that's 3 divided by 2, plus or minus 2 divided by 4 times square root of 3, or in other words, a half times the square root of 3. So this is just a reminder basically for you if you forgot how the ABC formula works. So that's something that we're going to expect that you know, or know how to look up at least sufficiently fast that you can use. So that was a quadratic equation. So the next bit is going to be solving linear equations into unknowns.